Good day, Sir Alquino. I'm the Cadet Ayan Sigun Magallaon, and we are the Group 6, and we will discuss about the gyro compass. So, the gyro compass, although it is popularly believed that the gyro compass indicates true north, this is not necessarily the case. The gyro is subject to course, speed, and latitude errors. These are kept to the minimum by input corrections. The gyro error is rarely more than 1 or 2 degrees for a correctly maintained gyro. To avoid confusion with magnetic errors, gyro error is named high or H or low or L. So gyro error is named high when the gyro course or bearing is higher than the true course or bearing. Therefore, high error must be subtracted by the gyro reading to obtain the true reading. The opposite applies to low error. So the example of gyro compass is, gyro error is known to be 2 degrees high. The true course to be steered is 76 degrees. What is the gyro course? So the true course given is 76 degrees. Gyro error is 2 degree high. The gyro course that you will add the true course and the gyro error. So the total gyro course is 78 degrees. A bearing taken with the same gyro gives 246 degrees. What is the true bearing? So gyro bearing is 246 degrees. Gyro error is 2 degrees high. So you will subtract the gyro bearing and gyro error. So the total true bearing is 244 degrees.
Relative bearings. So when bearings are taken using a Pelorus or by radar with an unstabilized display, ship's head up, the bearing taken will be measured relative to the ship's head rather than north. So such a relative bearing must be applied to the true ship's head to arrive at a true bearing for plotting on the chart. This will entail changing the compass course to true and then adding the relative bearing if in 360 degrees rotation. So in short, relative bearing refers to the angle between the craft's forward direction and the location of another object. So using 360 degrees rotation is now normal practice, but if the relative bearing is a given number of degrees, green or starboard, then it is also added. So, if the relative bearing is a given number of degrees, red or port, then it is subtracted. So, in the example below, the relative bearing would have been red 86 degrees. To subtract this from the true course, it would have been necessary to first add 360 degrees. So, the answer is 352 degrees.
Hello, good day sir. So I am the Cadet Carjo Petmancao. So this is the example of relative bearing working. A vessel is steering 073 degrees. Compass 073 degrees. Deviation is 4 degrees west. Magnetic is 069 degrees M. Variation 9 degrees east. True 078 degrees. The relative bearing of Edward Island Light is 274 degrees. So what is the true bearing of Edward Island Light? The relative bearing is 274 degrees. The true bearing is 352 degrees. So we know how to consider the checking of deviation card and keeping a record book. To find compass error by observation, if there is some doubt as to accuracy of deviation card or any case as a periodical check, the deviation can be determined by one of two simple methods. By transit bearings, when two well-charted objects are in transit, a compass bearing is broken. The true bearing is taken from the chart using parallel rulers. Comparison of the compass bearing and true bearing gives the compass error. A transit bearing when two or more objects lie in the same line, as in figure 2.17, if the deviation is required, it is calculated by applying the chart variation to the compass error. Try checking the compass error using an azimuth circle on your compass and a transit bearing. A more difficult one is using a pelorus for a relative bearing, then converting this to a compass bearing.
So ask the master to show you, then practice. Example, in this case, a bearing has been taken of leading 0.45 degrees. So our true bearing is 0.45 degrees, and our compass bearing is 0.48 degrees, and our compass error is 3 degrees west, and our variation is 11 degrees east. Therefore, our deviation is 8 degrees east. So next slide. So compass error by transit using azimuth circle. So as you can see on the drawing above, by courtesy of Small Ship's Manual, in the second method, you require to know your exact position. This can be obtained by knowing your corrected GPS. Why is it important to know our corrected GPS? So GPS is very important because it is the satellite navigation system. It consists of 3 parts that include satellites, receivers, and ground and stations. So the GPS is used for providing the information about time and location. So second is ranges from radar. To get the range of radar from the above equation, we can conclude that the following conditions should be considered in order to get the range of radar as maximum. So peak power transmitted by the radar, PT, should be high. Gain of the transmitting antenna, G, should be high, and radar cross-section of the target, or should be high. Then last is ranges from vertical sextant angles. So the object should be on the chart and well distanced from the vessel. So next slide, by bearing from a known position. So when the vessel's position is accurately fixed, a compass bearing may be taken of a well discharted and distant object, say a tower, as in figure 8, 2.18. So the true bearing can again be taken from the chart using parallel rulers. Calculation made as above. So any small change in the vessel position while swinging will have a negligible effect on the true bearing if the chosen is sufficiently distant. That's all, sir, and thank you.